Hey guys, I'm Andrew. Today we're standing here in the products area at Haas, and I've got Alex with me. He's gonna walk us through a cool demo that he's doing in conjunction with Autodesk.
Yeah, what's up guys? So this is for the upcoming Autodesk University. This is the part they asked us to make for them to help out with their trade show. It's a neat little part. It's got some interesting fixturing, interesting cam tool paths, so let's take a look at how we made it.
So looking at this part, it kind of seems like it's kind of a 3-axis part, maybe not lending itself to being made on the UMC 500 here.
Right, you're exactly correct. And it would have been cool to try and do everything in one op, typical 5-axis stuff, you know, tab it off and get the cool jiggle going. But there's just so little support that even like fixturing straight up and down like this, I'd be making a 40 thou thick piece 3 inches away from the vise. It was going to work better 3-axis.
And you also had a UMC 500 going to this particular show before you even knew that you were making this part, right?
Right. So this could obviously be done on a VF2, anything like that. We just have a double station vise fixtured straight to the table here. So there's no 5-axis moves at all. This is sometimes...
So you're not doing 3+2 at all. It's all completely 3-axis.
No, like, you know, the advantage to 3+2 is you can hit all 5 sides of your part at once, and the second op is generally just face and deck off material. And as you guys will see, that's exactly what we're doing here with a 3-axis setup.
But it is a simple setup that you can just load onto this machine without worrying too much about, you know, special fixturing and anything like that.
Exactly, yeah. We've got this cool double station vise like I mentioned, and we're using that to hold op 1 and op 2 at the same time. So each time we push cycle start, we get a finished part out of the machine.
Okay, so Autodesk gave you a model for this part, and then it was kind of up to you to fixture it however you wanted to do it. Why did you choose this 2-station vise?
Well, let's go back a little bit. So I didn't have a dimension drawing or a typical blueprint like you get in a job shot. All they sent me was a model, and then so it's pretty much up to me to decide what was important here. So because this doesn't get any post-processing, we're giving them out at the show like this. The surface finish on the outside here, I figured it had to be really cool. It had to be good. It couldn't be rough or anything like that. And anytime I don't get a dimension drawing, for me that means I have to make it tighter, because I don't know if they've actually figured out, you know, can I be plus or minus 5 thou, or do I need to be plus or minus a couple tenths? So I made sure everything is pretty close to spec. Took a lot of light duty cuts, really trying to hold dimensional accuracy and getting a good surface finish.
And you kind of, I think we'll find out that you progress through the cut in a way that allow you to do some of the finishing ops earlier than maybe you would otherwise to maintain surface finish and those kind of things?
Yeah, right. So looking at the model originally, you know, this is a real thin-walled part. The first thing that jumped into my head was like, how can I reach the final side and not just immediately crush this no matter what I'm doing, putting it into a vise? So I chose to machine the inside of this part first. This way I could make all the features except for the front face in one operation, and to hold it for op 2, I came up with this neat little trick. I made a bunch of these spacer blocks starting at nominal width and went up or down a couple thousandths on each one. So I can just plop whichever one I think fits best in here. It's a little tricky.
You want it to fit pretty tight.
Send it home. You want it to fit pretty tight, and now this isn't going anywhere. I can put that in the vise and I can reef on that handle as hard as I want, and these walls aren't going to get crushed. The material is not going to deflect at all.
So as we're looking at right here, this is after of course, you finished the outside perimeter and you've dug the internal pocket out. But you're saying that you start with this outside perimeter first, and then I think you're progressively doing the inside, right?
Yeah, so typically you'd want to work inside out. Your parts tend to be a little stiffer that way. But in this case, I wanted that outside surface finish to be really good. And on the inside, you know, it's going to get snapped into an enclosure somewhere. No one's ever really going to see it. If there was going to be chatter, I'd rather it be here. So I elected to finish the outside almost immediately.
Let's talk a little bit about how you progress on the first op. Are you milling this entire thing out at one shot, or are you taking steps, or kind of how do you approach that?
I would love to mill this entire thing out in one shot, but if I tried doing that and making these little tiny tabs up here at the top, it's going to vibrate, it's going to scream like crazy, they're going to look awful. So my first operation is I just come in with a 1/2-inch end mill, rough out these tabs at this layer right here, leave these tabs super thick. I left 50 thou on either side, so that 1/2-inch tool with all its tool pressure isn't going to deform them. And then I come back in immediately with a smaller tool, clean them up, finish it at that layer while this thing's still filled with material. And
so you're basically right at this deck right here.
Exactly,
right?
And that's kind of the name of the game when it comes to these thin-walled parts. Is you just take small step downs, always try and cut where you have rigidity.
So how many steps are you taking before you're down here at the bottom?
So I'm doing 3 step downs. Each is about 3/8 of an inch. They kind of vary from 1/4 to a 1/2 inch. So the next step, I rough out this layer right below these slots here. So I have enough room to come in with a small tool and then finish the slots. And again, this is still almost a solid chunk of aluminum at that point. So it's not an issue that these things are so small. There's no deflection, there's no chatter.
Right, so each time you're coming right below the next thin feature or wobbly feature you want to make, and you're not going below that.
Exactly,
Right.
and then
That's
so
cool.
as soon as I get down into this pocket, so this top layer, I can just rough off and the chips aren't gonna go anywhere. But as soon as we start actually pocketing, the first thing I decided to do was poke a gigantic hole in the middle of my part. So this allows me, well, number one, high material removal rate, so it gets rid of a lot of that material quick. And it allows all the coolant to drain, it allows all the chips to drain out of this part, so we end up not cutting in a swimming pool full of swarf.
Right. And in this case, you were lucky that there was a big window on the back of the part. So you had a perfect place to put this drain hole.
Right, yeah, that's one of the cool things about doing a part with so much material removed is you can poke pretty much as many holes as you want. And
Right.
that's one of the things. This isn't an optimized program either. I'm sure there are a ton of ways to make it faster. This one is just, it's what I did to make the first one come off the machine good.
Would you ever poke more holes with a big inserted drill to get even more, just to remove more material quicker?
Oh yeah, 100%. This was just, we needed to get this done quick. I knew it would work.
Right.
The machine we're using also doesn't have TSE, so I was a little bit concerned on insert life, just running flood coolant with such a big tool, but.
Cool. Nice. So then you get to the bottom, you get to the final layer you're removing, and that's when you're adding these extra, kind of extra features below that, right? Extra pockets.
Yeah, exactly. So I'll rough a layer about 1/4 to a 1/2 inch down, come in with a finish tool, finish that layer. So you're taking a smaller cut than you would finishing the entire side, and it's right next to a whole block of material, so it's still pretty rigid. And then I just repeat that process a couple times. I step down again, rough it out, come in with the finish tool, finish while it's rigid, rough out the final layer, finish the walls again, and then step down and cut out all these pockets. So the whole time I'm trying to make sure I have as much material supporting these walls as I can.
Before you take this outside cut, are you doing one final pass on the inside?
Oh no, so
Or are you doing this outside surface first in terms of, you're doing this one first, right?
right, I actually
Okay.
typically you would want to start on the inside and work your way out for moment of inertia and keeping stuff rigid physics.
Moment of inertia, wow, right on.
But in this particular case, like I mentioned, the outside of this part really needs a good finish. There's no post-processing. I didn't want to be Scotch-Brighting anything in the middle of a trade show. So I actually rough and finish the outside of this part almost immediately, just to ensure that there's going to be no chatter and we get a nice good finish.
So when you're finishing, so now you don't have support out here though. When you're do you end up coming in and doing one super light cut on this wall at full depth? Or are
Well,
you just finishing each stage?
I finish in stages. So again, like that final finish cut is running a spring pass on these upper 2 layers, but they've already been cut a few times. So there's really only like a 10 thou radial or 10 thou width of cut and a 1/4 inch depth of cut. So it's a real light cut on these final walls. And then I come in, I chamfer every surface. So this thing's ready to go.
Right, so you're not going to do any more work on this side once you've flipped it.
Exactly.
Right.
It's,
I guess, how would you?
yeah.
So on your op 2, do you have clearance for these tabs and some of this other stuff here?
Yeah, so the other neat thing I did with my second op jaws was I actually got some oversized pieces of aluminum and I cut my own jaws. As you can see, the stock size is about in line with this vise. So my part was still going to be overhanging and I didn't want the material to bow out like this at all when I clamped on it. So I wanted walls on either side of this to help support that.
Nice.
So I made some oversized jaws. I just poked some holes to act as clearance for these little tabs with a 1/4 inch drill. And now when that thing's in there, it's sandwiched. It's not going anywhere. I have just a couple thou clearance in X and it's solid.
So you kind of, are you nominal along Y and then a little clearance on this side maybe? A little more clearance on these sides?
Exactly. Well, Y you get the jaw adjustment, so cut that
right,
nominal.
you're gonna clamp
and then
there.
I've got 10 thou clearance in X and I'm just positioning along the left side.
Nice.
So if there is deflection, it's super minimal.
Cool. So the tooling you're using, this is pretty straightforward. I think it's like some end mills and a face mill.
Yep, pretty much using just a half, quarter, 3/8, and a 1/8 end mill. For my rougher,
But yeah, you were saying that one of these end mills is kind of different.
yeah, so my 1/2 inch rougher, I'm using one of our DLC coated end mills with these chip splitters here. So it's just allowing me to get rid of that material a little quicker. And then the chip management, again, I've got my big hole in the part, but this makes even smaller chips, so the coolant just washes
You're chopping
it
them up, so you're
so
not these long chips.
Exactly, just washes it all out like a drain.
And you're saying you're running that thing twice as fast as you would the regular
Twice as
polished one?
fast. Well, I've pegged the machine at 10K no matter what. with
Right, it's not a
aluminum
super
here.
speed, so.
But yeah, but chip load double. Normally I'd run around 3.5 thou with a polished end mill. This one I'm running at 6.
Cool. Why not, right?
Yeah.
So you're talking a little bit about using the probe in this. What are you using the probe for in this particular program?
Right. So we've got a prototype VPS template that will allow for in-process inspection here. So I decided to test it out on this machine. So I'm coming in. As soon as my first op is finished, I'm probing this width right here. And I actually have the controller tell me what that dimension is and what size spacer block I should be using to put in there. So I don't even need my calipers at all for this, really.
Nice, nice. Okay, so you've done all that fancy work on the front side. Now you're plopping that spacer block in there, flipping it around, and putting it into your soft jaws. What's left when you get to op 2?
Exactly. Op 2 is super simple. So I just put my block in, get it around the tabs.
Don't break the tabs off.
There we go. Plop it in the soft jaws, and then we just deck this off and throw some chamfers on, engrave some logos, and that's it. It's done. So it's about as simple as it gets for a second op.
Right. And the only thing at that point that's being finished is that top face and then the chamfering.
Exactly.
Cool.
Everything else was done in op 1. So, as much as we love to show off our 5-axis, there's really no point in a setup like this.
Yeah, and this is a machine that you had that was going to the show, so you needed to use that anyway. But it does underline that if you had this machine sitting in your shop and you didn't have a fancy 5-axis job to put on it, you'd probably still do this because that way you're employing that spindle.
Right, yeah. Rather than letting your machine sit, you can always throw on a double station, get op 1 and op 2 fitted on there. It is a smaller table than a VF, but there's ways around it.
Yeah, cool. All right, well, I guess that about wraps it up. I know you've got lots of testing to get back to, Alex. Thanks for walking us through the demo.
Of course, no problem. See you next time.
Thanks, guys.